Today we're going to start with the chapter of further trigonometry, and so we're going to complete the whole syllabus for trigonometry in mathematics 4024 for the GCSE O-level syllabus. First up, we have bearings. So bearings are used to measure the direction or the angle of movement from one point to another, and they're in the form of angles. There are three basic rules we need to keep in mind when we're calculating the bearings. Firstly, that the bearings must be measured from the north. So the bearing at north is 0, and the bearing is always going to be measured from the north, and we're going to move clockwise. If we move anti-clockwise from the north, it's always going to be wrong. And lastly, our bearing must contain 3 digits. So if our bearing is coming out as 175 degrees, so that's correct because that's in 3 digits. But if it's coming out as 40 degrees, so we're going to write it in the form 0, 4, 0 degrees. Otherwise, it won't be correct. Then, let's take an example of a question of a bearing. So I'm standing at point A, and I want to reach point B, and I want to calculate the bearing at which I should move to reach point B from point A. So the first thing I'm going to do is draw lines to north because that was the first rule in bearings. And next, from my ease, I'm always going to connect both of the points. In any question of bearings, you're going to connect both the points if they're not connected. Otherwise, everything's going to seem confusing to you. Then, since we're going to move clockwise, and I wanted to find the bearing from A to B, so moving clockwise from the north line to the line connecting A and B, I need to calculate this angle. And this angle comes out at 70 degrees, so I'm going to write it as 070 degrees because that's a third rule for bearings, that it needs to be in 3 digits. But say I reach B, and now I need to find the bearing at which I should move to reach point A. So I'm going to move clockwise from point B to the line connecting A and B, and I need to find this whole angle. How will I find this angle? Other than using a protractor, a more accurate method would be to use simple geometry. So I have this as 70 degrees, and since they're interior angles, this comes out as 110. 180 minus 70 is 110. And then I subtract 110 from 360 to give me 250 as the bearing from B to A. Next up, we have the Pythagoras Theorem, which is very easy and we're familiar with it. The Pythagoras Theorem simply states that any two lengths of a right-angled triangle, the square of these two lengths is going to equal the square of the hypotenuse. The hypotenuse is the longest length of a right-angled triangle, and it's the opposite length of the 90 degrees. So if I have any right-angled triangle, I know that the sloping length or the longest length or the length opposite the 90-degree angle is my hypotenuse. So I'm going to square the other two lengths and I'll find the square of the hypotenuse. So if I have the hypotenuse given as 5 and I have one of the lengths given as 3, I can simply find the square of 3, add it to the unknown length, and the square of the hypotenuse. I just put in the values in the formula, and in that manner I get b squared as 16, and my b comes out to be 4. So that's simply the application of the Pythagoras theorem. Then we have sine, cosine, and tangent ratios. So first we need to know how we're going to label the lengths of a right angle triangle. So my unknown angle will be theta, and the length opposite the 90-degree angle, as we discussed, will be the hypotenuse, and the length adjacent or tangent, or the length touching the angle, is going to be the adjacent, and the length opposite to the angle is going to be the opposite length. So for that, I have a mnemonic to remember these three ratios, SOH, CA, and TOA. SOH means S for sine, O for opposite, S for hypotenuse. So the sine of theta, the sine of the unknown angle, is equals to the opposite length upon the hypotenuse length. And similarly for cosine and tangent. So, for example, I have any values. I have theta as 30 degrees, and I have the hypotenuse as 5, and I want to find the opposite. What am I going to do? What is the formula connecting the hypotenuse and the opposite? Since these are the two values needed, I know the hypotenuse and I want to find out the opposite, O and H, so solve. And so for that, I have the angle theta. I'm going to find the sine of theta, and that value is going to equal to the opposite upon the hypotenuse, which is 5. And by cross multiplication, I can easily find the opposite length. Then the angle of elevation and the angle of depression. So this is the normal length. This is a normal line to which I'll be looking if I'm looking straight. So if I'm looking exactly straight, this is the horizontal line. This is the imaginary line that will form. But if I want to look at an object above this line of eyesight, the angle at which I'll move my head upwards to look at, say, an aeroplane will be the angle of elevation, because I'm moving my head upwards at an angle to look at an object upwards. So that's the angle at which I move my head is the angle of elevation. And if I move my head downwards to look at an object downwards, so that's going to be my angle of depression. How can I use the angle of elevation and the angle of depression in questions? So here the question, I have a question here, and it already gives you the hint that you can use SOHCAHTOA here. So I want to find the length of the building from here till here, and I have the angle of elevation of 60 degrees. When I'm looking upwards at the top of the building, I move my head upwards 60 degrees, and I am standing at a distance of 10 meters from the building. So to find the height of the building, I can use TOA. Why? I need to find the opposite value. This is the opposite value. And I have the adjacent length as 10 meters. This length is opposite to the angle, so it's opposite, and this is adjacent. So this is known as the adjacent length. And then I'm going to use TOA, tan theta, or tan 60 is equals to opposite upon 10. And I'm going to get my height as 17.3 meters, but this portion would still be left. I found the length of this portion, but this portion is still left. So I'll add my own height, if this is me, or whatever the height of the person is given, to the height I found to get the total height, which is 19 meters. The building is 19 meters tall. Next, we have two simple formulas that we can use when we have a value in terms of sine, but we need it in terms of cos. So we can use this formula: sine theta is equals to cos 90 minus theta, and cos theta is equals to sine 90 minus theta to convert the angles. Then we have a difficult topic, which is the sine and cosine rule. So we need to know how we label any non-right angle triangle. For a right angle triangle, we use the terms hypotenuse, theta, opposite, and adjacent. For a non-right angle triangle, we take any angle as A and the opposite length as A. We take any angle as B and the opposite length as B. And we take any angle as C and the opposite length as C. So the angles are always going to be in capital letters and the lengths are always going to be in lowercase. And so the sine rule states that any length of the non-right angle triangle upon the sine of the corresponding angle will equal to another length of that triangle upon the sine of that corresponding length. So for example, I have this question here, and I want to find out x. So if I quickly label all my values, so if I label this angle as A, so if this is A, this length becomes A because they're opposite. If this angle is B, this becomes length B. So length B is 7 and length A is X, angle A is 80 and angle B is 60. To find X, I'm going to use the sine rule here, and I can easily put the values in. So sine of 60 upon 7 is equals to the sine of 80 upon X. And through cross multiplication, I can find out my value of X, and this is the manner in which I can apply the sine rule. But for the cosine rule, it's a little bit lengthy to memorize, but you can memorize either this one or this one. They both are rearranged. So I'll use this one for finding sides and this one for finding angles. The simple formula is a squared is equals to b squared plus c squared minus 2bc cos a. So I'm going to square my values. I'm going to put in values here to find another value. For example, I want to find one length. I have its corresponding angle and have the other two lengths. So I can use this formula. Or if I have all three lengths and I want to find out an angle, I can use this formula. Then if I want to find out the area of a non-right angle triangle, I cannot use half into base into height because I don't have a base and a height here. This is a non-right angle triangle. I'm going to use half into AB sine C, and this formula is true for any triangle. So I can even use it for a right angle triangle. That is going to come out as the right answer. So half into AB, A and B, these are my two lengths, and sine C. So if I have these two lengths and I have this angle, I can multiply them and then divide them by 2 to get the area, which is very easy. And then we have three-dimensional trigonometry. 3D trigonometry seems very difficult. If you're given a pyramid, you get confused that you haven't studied this. But the simple thing you need to do is to create a right angle triangle here for your ease. When you have a right angle triangle here, you want to find this length. You formed a right angle triangle. You have one length of this. You need to find the other length, and you need this length as well. So as you can see, the base is a square. It tells you it's a square-based pyramid. Two lengths are equal, so which means that the other two will be equal as well. And so to find the diagonal of the square, why will I find the diagonal of the square? Because this whole length, this base length, is half of the diagonal. So the formula for a diagonal is side into under root 2. Side is the side of the square, 20.6 into under root 2. And whatever my value comes out to be, it's going to be the value for the whole diagonal, and I'll divide it by 2 to get the value for this base length. And once I have this and I have this, I can use the Pythagoras theorem to find AE, this length. And so that's simply 3D trigonometry. Now let's have a look at some questions and just how basically to solve them. So I have this triangle and I've been given some values for sine, cos, and tangent. I need to calculate AB. I will first simply divide this into two equal right angle triangles. And then to find AB, this length becomes 16 because I divide into two equal triangles, so 32 upon 2 becomes 16. When I have the 16 and I want to find the hypotenuse, this is the adjacent, this is adjacent to theta. So A and H, I'm going to use cos theta. And so that's 8 upon 17. So what is cos? It's the adjacent upon the hypotenuse. The adjacent is 16. Hypotenuse is x, we don't know that, is equals to cos theta. Cos theta is 8 upon 17. And through this, you can get your value as 34. And when they ask you to find out the area of the triangle, you will use which formula? Half into base into height? You can use it, but it's going to be too lengthy. And then you need to remember not to add the half because you have to multiply it by 2 in the end. So you'll simply use half into AB into sine of C. And so half into 32 into 34, which are two of my lengths, into sine of theta. I don't know what theta is, so I'll just use the value for sine theta, 15 upon 17. And so half into 32 into 34 into 15 upon 17 will give me the answer for area. Then I have another question. Over here, I have a scalene triangle with the lengths given in unknown terms and one of the angles. So since this is angle A, this becomes length A, this becomes length B, since this is angle B, and this becomes length C. They're asking me to form an equation in x and show that it simplifies to this. I can't use the Pythagoras theorem. It has a square in it. So I need to use a formula that has a square in it. So Pythagoras theorem, I can't use it because that's for right angle triangles and this is a scalene triangle. So I'm going to use, this is a non-right angle triangle. So I'm going to use the cosine rule, which is a square is equals to b square plus c square minus 2bc cos a. If I put in all the values, if I put in the lengths for a, b, and c, and I put in cos a as cos 60, it's going to form this equation. Then to solve this equation, I'm going to use the quadratic formula. Why? Because it says decimal places, and whenever your answer to a quadratic equation comes in decimal places, it means you have used the formula. Your answer will come as negative and positive. So you're going to ignore the negative answer because x here is your length, and your length can be negative. So you're just going to use the positive answer. So the positive answer, x, will become AB. So you can write whatever value for x comes out. And for AC, you're going to multiply that value by 2 and add 3 to it to find both of your lengths by replacing the values you find from the quadratic equation. Then you want to find the area of triangle ABC. You can simply use half into AB into sine C because, again, this is a non-right angle triangle. And then lastly, we have a question on bearings. So I have points A and point B. That's the only thing the question is asking me, of A from B. And so what do I do first? I draw lines to north, which are already drawn. I connect A and B. They're already connected. Then the bearing from A to B is 40. You can see that the bearing, clockwise bearing from A to B is 40. Bearing is always clockwise. But the bearing A from B, which means B to A, what is that? I'll move clockwise from B to the line connecting both of them to find this angle. What will I do? Since these are interior angles, this becomes 140 because 180 minus 40 is equals to 140, and 360 minus 140 becomes 220. So my bearing is 220 degrees.